In this lecture, we are going to talk about what is text classification, what are all the real world use cases where text classification is applied, and then the different approaches to implement the text classification, where we are going to implement the text classifier using traditional machine learning model versus the language model based approach. And towards end of the session, we are going to compare these two approaches and then try to find the pros and cons of these two approaches. So without further ado, let's dive into this session.
In our daily life, we already experience these AI-based text classifications. You might have noticed that in Gmail, your emails are classified under different categories. Here, the objective is to classify emails into categories like work, promotions, social, spam, etc. You might have also noticed that sometime your bank calls you to check if certain transactions was made by you or not. This is because their AI system might have suspected some fraudulent transactions, usually high value transactions, and classified it as fraud. This is also an example of text classification using AI. Here, the objective is to classify a transaction into categories like fraud and not fraud. When you write product reviews on Amazon or any other platform, your review comments are used to generate a customer sentiment about that product. This is again done through text classification AI system. Or when you provide some review about some movies or some shows on social media platforms like Facebook, Instagram, X, or YouTube, these comments are then used by the AI system to generate the viewer's sentiment about that movies or shows. This is again done by text classification system. Here, the objective is to classify user feedbacks into positive, negative, or neutral. Another example of text classification is log classification. Imagine you are monitoring a software system and your task is to analyze the log file. Here, objective is to classify system log file into different categories like error, warning, debug, or info. When you call or interact with any customer care service, in the back end, they have something called a trouble ticketing system. For instance, in a typical IT sector, an end customer might call customer care to complain about an issue or inquire about a new service or product. When this happens, the customer care agent generates a ticket and issues a ticket number to the end user. This ticket then categorized and assigned to the appropriate team for resolution by technical team. Then the respective team or department start working on this ticket. And finally, when issue is resolved, end customer is updated. Here, the objective is to classify a ticket into predefined category and assign it to the respective team. Putting them together, these are some of the real-world use cases of text classification. In the left side, we have traditional classifier. These are conventional machine learning algorithms like NAB-Bayes, logistic regression, decision tree, and more advanced ensemble methods like random forest, gradient boosting, since, and XGBoost. These models rely heavily on structured training data, feature engineering, and sometimes requires extensive pre-processing. Each model has specific strengths such as decision trees being interpretable and ensemble methods offering strong performance in complex tasks. Traditional classifiers work well for structured data, but may struggle with understanding nuanced language features without significant feature engineering. And in the right-hand side, we have LLM-based classifiers. These leverages the large language models, which are pre-trained on vast amounts of text data and can understand complex linguistics patterns. With LLMs, we have the option to build from scratch by training the model on large data sets, which is resource intensive, of course, and then use prompt engineering on an instruction-tuned model where we carefully craft prompts and guide the model to classify text correctly without extensive training data. And then the third approach is fine-tuning on a base model for domain-specific applications, allowing LLMs to adapt to specific tasks or datasets. The key takeaway is that LLMs can often deliver high performance in text classification tasks due to their pre-trained language understanding, but they require prompt engineering or fine-tuning to be effective. Traditional classifier may still be suitable for simpler or more structured tasks, but may lack the flexibility and linguistic understanding of LLMs in complex text classification scenarios. Let us try to understand the overall process or pipeline for building and deploying text classifier in traditional and language model-based approach. Sample collection. So in traditional classifier, it requires a large data set with many examples in each class. The goal is to gather enough data to ensure the model can generalize well. In the language model-based classifier, sample collection is still needed, but on a much smaller scale. Since LLMs can perform well with just few short prompts, only a small representative set of examples is required. This drastically simplifies the collection process. Then data preprocessing. In traditional classifier, extensive preprocessing is required, including feature extraction, cleaning, and transformations. Often, domain-specific feature engineering is needed to make the data suitable for the model. Whereas in language model-based classifier, preprocessing is simpler, mainly focusing on curating a handful of clear examples. The emphasis is on ensuring that the few short examples are clean and representative without the need for complex feature transformations. Then feature engineering or prompt engineering. So in traditional classifier, it requires feature engineering to extract relevant patterns, often involving transformations like TF-IDF or embeddings. This stage is critical for model performance. In a language model-based classifier, instead of feature engineering, prompt engineering is used to guide the model. Here, carefully crafted prompts combined with few short examples help the LLM understand the task without explicit feature extraction. Then train test split versus few short validation set. So in traditional classifier, train test split is essential for training the model and evaluating its performance. The model iterates over multiple epochs and validation set to find the optimal parameters. Now in the language model-based classifier for LLMs, few short examples act as in-context guidance rather than actual training data. A small validation set can be used to test the prompt quality, ensuring the LLM performs well without iterative training. And then model training or model selection and in-context learning. In traditional classifier, it involves model training where algorithms like decision tree or SVMs or any other traditional classifier learn from the data. This process can be time consuming, especially with large data set. In language model-based classifier, model selection and in-context learning take the place of training. The process involves selecting a suitable pre-trained LLM and using prompt engineering or few short examples to adapt it to the classification task. This bypasses the need for extensive model training. Then comes the model evaluation. In traditional classifier, evaluation typically includes matrices like accuracy, precision, and recall, and F1 score on the test set. This step is iterative as model adjustments are made to improve performance. In language model-based classifier, similar evaluation matrices are used, but the focus is on validating prompt effectiveness and in-context learning quality. Adjustment may involve refining the prompt rather than retraining the model. And finally, deploy and monitor. In both approaches, once a satisfactory model is obtained, it is deployed and monitored in production. Now, monitoring ensures that the classifier continues to perform well with real-world data, and adjustments can be made as needed. Another key point to note here is that in both these approaches, these are the steps which are iterative in nature. Okay, so now let us dive into the real code and see the different approaches like the traditional classifier versus language model based classifier on some sample data set. Okay, so this line is to import the pandas library and give it a shorter name like PD to make it easier to use in the code. Now, Panda is a popular library in Python used for data manipulation and analysis. It makes working with data much simpler. And then here I'm just mounting my G drive, Google Drive, where I have kept this sample data file. And then finally, I'm loading that sample data using read_csv function from pandas library. And just to tell you that this sample data is of trouble ticketing system. So this data is from a banking domain. So you can, let us see, how this data looks like to make it more clear. So this data is for a banking domain. So you can imagine this as these are all the ticket descriptions are nothing but the customer complaint. And in the backend, somebody is assigning this ticket to different category or different departments. Now, if you look at this data, we can make some observations. Number one, each ticket descriptions is enclosed in double quotes, which can be removed. These extra quotes may interfere with text pre-processing and analysis. So therefore, it is better to strip them during pre-processing. And the second one is for the category column, where we can see that, like especially for account issue, some of the entry having account issue in capital A and capital I, whereas some is having account issue with small letter A and small letter I. And because of this, it can lead to problems when training a model, as it may treat categories with different categorizations because of this lowercase and uppercase. Now, to address these issues, we need to apply the following transformations. So number one, strip any surrounding codes from each entry in the ticket description column. And then second one is like convert all entries or all content in the lowercase so that it maintains the uniformity and you don't have this uppercase, lowercase challenges. So these simple pre-processing steps will improve the consistency and quality of the data, which will ensure that minor formatting differences do not affect model performance. So let us implement these transformations. Okay, so here we have these two functions. One is this str.lower, which is string.lower. So here what we are doing for this column, ticket description column in the data frame, we are going to update this column with str.lower, which means the value of this column will be put in lowercase form and then kept in the same column. Similarly for the category column. And the second transformation we are going to do is we're going to remove the quote, leading and the trailing quote from the ticket description, which we saw. So here again, for the ticket description column of the data frame, we're going to use a string str.replace function where we're going to replace this quote with blank. So let us execute this. And then when you now see your data, now you see those leading and the trailing quotes are gone, and then this account issue both are in the same case, so no problem at all now. Okay, now let us move further. Let us again do some data exploration. So checking class imbalance. So in traditional classifier, when you train your model, before you train your model, you need to analyze your data to see if there is any class imbalance. Now, we see that there are just very few samples, and some categories are highly imbalanced, with classes like account issues and transaction issues having many samples, while others like network issues and performance issues have very few samples, just 4 samples. These imbalances poses challenges. Now, traditional classifier may become biased towards majority classes, leading to poor generalization for underrepresented classes. Techniques like resampling and class weighting can help, but they add complexity and don't fully address the problem, especially when certain classes have very few examples. This is where LLMs offer a distinct advantage. Now, LLM, through few shot learning, can handle classifications even with minimal examples of each category. By providing a few representative examples in a prompt, LLMs can understand and generalize category distinctions without the need for extensive training data for each class. LLMs don't rely on the large sample size in each category, so their pre-training on vast dataset allows them to interpret the nuances of each classes based on the context. So they can perform well even with limited data in some categories. This means that LLM-based classifiers are more agile in situations like this, where you have limited or imbalanced data, as we see here. So here, the traditional methods may struggle without extensive pre-processing and adjustments. All right. Now for traditional classifier, first of all, we need to um, convert our data into a list and put them under X variable and Y variable. Now here X is the ticket description, which can be used as input data for the model, while Y, which will contain the categories, it serves as the labels or target values the model will try to predict. By having these as lists, they are in a format that is easier to use with various machine learning libraries such as scikit-learn, where you typically need your data in a list or array format. So let us transform them. Okay, so once our data is converted into list, now is the time to split that into training and test set. We are going to use train test split function from scikit-learn library. This train test split is a function which is one of the most popular Python library for machine learning. This function is used to split data into training and testing sets, which is an essential step in machine learning to evaluate how well a model performs. So now, once the data is split into training and test sample, we need to convert our data into a numerical format because machine learning models do not directly work on the textual data because they try to learn the patterns from the numerical data points. They try to build the statistical relationships between the data points, and therefore these textual data need to be converted into numerical format. And to do that, we are using TF-IDF vectorizer from scikit-learn library. So this will transform our x underscore train and x underscore test into the vector form, like x underscore train underscore vector and x underscore test underscore vector. So let's do that. Okay, so once our data is now transformed into numerical format, it is time to initialize our classifier model. So here we are going to initialize the decision tree classifier from, again, scikit-learn library. And then we are going to call the model.fit function to train the decision tree classifier. So let's do that. All right, so the model is trained. Now we are going to call the predict function to generate the prediction on the test data. And here we have the prediction made by the trained model. Now we are going to use the confusion matrix again from the scikit-learn library to measure the accuracy of this classifier. So let's see that. Okay. So this is the confusion matrix of our trained classifier model. Now, if you want to learn about the confusion matrix, there is a separate video, and I will put the link of that video in the description section where you can learn about the confusion matrix. And this is the classification report of the classifier. Now, in this notebook, I have also trained a different classifier, different traditional classifiers, not only the decision tree. So you can go through this notebook and just explore the different traditional classifier. And once your classifier is trained, then you can use that classifier on a new data set to see how your model is performing. And then you can save your model using joblib from Python. So you need to install the joblib, then import the library, and this is how you can save the different classifier models. And you also need to save your vectorizer, so TF-IDF vectorizer. And then once you save this, then in the deployment, you can again import the joblib, and then you can load your saved models, and you can load your saved vectorizer. And then you can use again as a normal way on the new dataset. So you have this text to be classified, then you first transform that into numerical format, and then you call the predict method of that classifier, and then it gives you the prediction. All right, so far we have talked about the traditional classifier. Now here onwards, now we are going to use an LLM based classifier. LLM based classifier we are going to implement using OpenAI. So we are going to first install the OpenAI library, and then we are going to import the OpenAI libraries. Then we are going to use this user data from Google Colab, where I have configured my OpenAI API key. So using that OpenAI API key, I'm going to instantiate a client object for OpenAI, and this client object will be used to access the OpenAI APIs and the models. Now I have this helper function getResponse. GetResponse function is where I'm calling the OpenAI API. I'm going to use GPT 3.5 turbo model, and the messages are the message list where I'm going to pass on the system and the user prompt, and the temperature value I'm setting 0. And this is how I'm going to get the response from the GPT 3.5 turbo model. So let us initialize this helper function. We will first try with zero shot prompt. So say this is your string or text to be classified, and in the instruction we are saying that you act as a trouble ticketing system, and your task is to classify the following trouble ticket, which is the user input, in one of the category. And you see these are the categories which was there in our sample data. So now here we are not doing any training or any pre-training of the language model. Rather, we are using a pre-trained language model, which is GPT 3.5 Turbo from OpenAI. But through instruction prompt zero shot, we are stating in which category to be classified. So let us initialize this, and let us call our helper function and see the response from the model. Now here, this card reader is not working. The GPT 3.5 Turbo with zero shot prompt classified this as a hardware issue. So this is zero shot. But in typical text classifier, you may need one shot or few shot prompting, because zero shot may not be sufficient. So therefore, in the one shot prompt instruction, you can see that we are providing one example sample to the model, and then we are asking the model to classify. So now model is going to classify this. So this part of the code demonstrates the few shot prompting implementation. So here, instead of providing no example or one example, we are going to provide few examples to the language model as part of the prompt instruction. Now here, what we are doing is like here we are going to get one sample for each category from our sample data. So this becomes our sampled examples, okay, that will be used as a few examples for the prompt instruction. And then here we have this few short prompt instructions, which is same instructions like classify the following ticket descriptions into one of the following categories, and also like you should not create your own category. So this is the few short prompt, and then in this few short prompt, using this few short prompt instruction, we are going to create our final prompt, where you see here we are just iterating over the sample example, and we are creating example text from the sticker description and the example category from the category. So the sticker description and the category is appended in the few short prompt instruction to add the examples. And then this part of the code will iterate over each ticket descriptions to get the predictions. So here we are actually now using the entire samples which was there in our sample data. So all the ticket descriptions is being now run through one by one, and the model's prediction or the LLM based predictions are captured in this predictions list. And later, now we will be using, once these predictions are done from the language model, which is done. So now we're going to use again the classifier models evaluation process, where we're going to use the classification report and the accuracy score from scikit-learn matrices to see the confusion matrix, the precision, recall, and F1 score. So this is how you can implement using LLM based classifier. So the key observation, you might have noticed that in the decision tree classifier, this was the classification report. This was for HTZ classifier, and for KNN classifier, this was the classification report. And this is the classification report when we implemented the LLM based classifier using GPT 3.5 turbo model. And this is when we used LLM based classifier using GPT 4 model. Now, so what we can conclude is that, so this is the accuracy versus implementation approach. So you can see the traditional classifier versus LLM based classifier for our sample data set. So to conclude, the traditional classifier versus LLM based classifier, this is what we can say. These are some of the advantages, and these are some of the disadvantages these different approaches has. So this is all about it for this lesson. Thank you for watching.